Okay, now that we have modeled the geometry, we had the key points, connected them with lines, so the shaft is modeled using line. But if you remember, each section of the shaft, if each segment has its own cross-section area, and we designed it, we specified that at the beginning. So you remember the segment one, where we had the bearing on left and right, both of them are gonna have, are gonna have same diameter, but right. So that one, the segment number, this first one between point one and point two, it's gonna have section one. See the section numbers are listed here. I had total 7. So that number one, segment number one is gonna have cross section area of number one. So I okay that. Then this, let me look at here. Then between point 2 and point 3, I'm gonna have section number 2. So between point 2 and point 3, which I have already selected, I'm gonna have section number 2. Yeah, section elements number 2. And then for, let's look at here, between point 3, key point 3 and key point 5, I'm gonna have section 3. So between 3 and 5, both of them, I'm gonna have segment number 3. So I'm gonna okay that, and then say for this assign number 3. Then I'm gonna have for number 5, and between 5 and 7, if you look at here, we have section number uh, 4. So I have to come here, say section number 4, and next I'm gonna say between 7 and 8. If you look at here, 7 and 8 and 8 and 9, I have number 5. So let me select on this one too. So I have number 5 for that guy, and I say okay, and then 7 and 8 and 8 and 9. Okay, and then we have between 9 and 10, number 6. 9 and 10, I have number 6. So this guy is gonna have section number 6. And then the last one, which is my bearing guy, with my bearing, it's gonna have my last section. Alright, so each piece of my shaft, it has its own assigned cross-section area, right, based on what you saw. Alright, next, to model this, to mesh this, I would like to just put one element per piece, per segment, and you don't need to actually, you don't need more elements. You're gonna see that this is gonna result in sufficient accuracy. So, and the reason I'm doing this, because another reason is that if I put many more elements, I'm gonna have a lot of nodes here which I don't need. I just need the point 10, point 6, and point 0.8, and point, 4 points. Look at here. I need deflection and slope point 1, point 4, point 6, point 0.8, and point 11. Right? Because those are the critical regions, critical components that are sensitive to my deflection and also slope. Other points are not important. So to do that, to do just one element per piece, I'm gonna say, you know what, for all lines, you saw what I did, manual sizing, all lines, I just want one element for all of them, one per segment. So this is how this is gonna be meshed. Alright, then you say okay, mesh, and all lines, I'm gonna pick all lines and mesh them. So we did that, right? So if you guys wanna see the list of our elements, you can come here, list of elements and all their attributes you can see here. Starting from left, element 1 has material 1. The type is just, we have just one type of beam element, and then the node number is 1 and 2, connecting that, and then section number for that is number 1. For 2, element 2, I have section number 2 and 3, and I have 3 for those elements, and then 4 and 4, 5 and 5, and 6 and 7. So it's like symmetric, right? So it looks like we did it right. So we have our mesh now, and every segment has its own cross-section area assigned to it. All right, so let's look at the key points. Right, let me ask it to replot and show me the key point. All right, so we have this model, right? So mesh done. We need to apply loads now. So we go here for preprocessor load analysis type. We already have it static. We are modeling this as a static loading, although it's like moving, but assuming that there is no acceleration, we are good. Okay, so define loads. First, I want to fix one end of the shaft with, okay, the left end of the shaft where I have a bearing. I'm gonna need to fix that. So on key point, at that point, what I'm gonna do to have provide equilibrium. So you guys saw what I did. I clicked on key points and then came here, clicked on 1, and let's see, where did that go? Okay, let me select it again and then say this one, number 1, key point 1, and here you have options one by one to block them, block motion. So I don't want to see any motion in X direction for that node, any motion in, I'm holding shift guys and click on that. For Y direction, I don't want that to move in that direction. For Z, I don't want that to move. And for, you see, rotation about X axis is just twisting the shaft. So for one end of the shaft, I need to fix it, otherwise the problem is not gonna, ANSYS is gonna give me error because this thing is gonna start moving. On one end, I'm gonna fix it. On the other end, on bearing the right side, I'm gonna let it move freely. Okay, so we see of all these, I have blocked them. On the right side, the bearing on the right side, let's see what we can do there. So as I said, okay, so you know what, we can let UX be free too, let that slide, because on the other side of the shaft I have that guy actually fixed in X direction, so this shaft is not gonna move in X direction. For Y direction, we can have it fixed, right? For Z direction, again, we have to have it fixed. For rotation, as I said, this time I can have it free, so just fix Y and Z, and X direction is free and all the rotations are free. So I'm gonna have enough I'm gonna have equilibrium here, so no worries about that. So then we have to look at our forces, right? We have to apply forces. So let's look at our forces. So these are like displacement, but I want to define now forces on key points, right? We had two forces acting on each. Okay, I think I'm gonna need to open my notes to show you the forces. Let's see, can quickly find it. It was page 90, I think, something. Okay, so let's see what we have. chapter on bearings. So, I want to show you the loads from, so hold on. Okay, you can look at your book too. So, okay, so these are my loads. You see on the gear, um, look at the gear. The first gear, you see I have force of 197 going down, right? And then I have 540 going to the left. Those forces are acting on the teeth, but I'm gonna ignore this distance, right? So you see that those forces actually, you see WR, that force, I can move it down, slide it down without having any effect on my analysis, and that one is the one that's making moment for me. But the other force, the tangential force, you see we have a diameter of the gear here, and if I move it down, I'm gonna miss the twisting angle, I'm sorry, moment, torsion, but that piece is not gonna affect my deflections due to bending moment. So that's why I don't need to, I neglect that. I'm gonna skip that. Okay, so I'm gonna apply those forces 197 and 540 actually to the midpoint of the gear on my model. So let's see what we have here, 197 and 540. Okay, so what was that point in my model? Let's look at that. I'm sorry, let's get here. So in my model, that was point number 4, right? So point number 4, I'm gonna apply a load there. So on key point, load number 4, I'm sorry, point number 4, I'm gonna have a force, and you look at, this is y going up, z is going to this direction. So that force is going down in y direction, right? The radial force, which I just showed you, is going down 197. But so it's going to be negative, but keep in mind that, you remember I said that I'm gonna consider my modulus of elasticity was in KSI, so this should be in kilopound. So my force is in pound, so let's convert it to kilopound. So right, so I have this force going down, and then I have another force again there, but this time force is in z direction, is gonna be positive z direction. And how much is that load? Is, let's look at here, as I said, 540. So let's apply that here, 540, right? And okay, so I have those two forces applied to that gear. And then for this one, I have force going down 885 for the other gear, and it's acting on key point number 8, right? So key point number 8, 885 going down. So let's look at that. I have key point number 8, and then I have in y direction going down negative 885, right? 885, you see here again. And I have that, and then I have another force going in z direction, and this time that one is going to be negative 2, and it was what, 2431. So 2431, so converting that to kilopound is going to be like this, right? So these are my two forces that I had acting on the shaft, and boundary conditions, the bearings, as you see I fixed them. So the first thing I'm gonna do is Now we are ready for analysis. So, let's analyze this. So, I go here, we define the loads, everything done. We go to solution, and now say I'm gonna solve this guy with current load case. So I say okay, and it's done. Solution is done.